For this demonstration, I'm going to use FreeCAD version 0.19, which was built on the 26th of May. Now the three bridle joints we're going to model today are the quarter bridle, the T-bridle and the mitre bridle. The joints are very similar, and I'm going to use this as an opportunity to try different techniques of modeling. First thing I'm going to do is create a spreadsheet that contains the common parameters used by the joints. So we'll create the new spreadsheet. We'll switch over to the spreadsheet workbench and create a new spreadsheet. The names of the parameters will be stored in column A and their values in B. Now, in order for you to use these parameters in a model, we need to create aliases for them in column B. So you can either do that by clicking on the column and then clicking on the set alias tool, and I'm going to make the alias the same name as the parameter. You'll see that the background of the cell is yellow, indicating that it has an alias. The other way to do it is to use a macro, which allows you to set up multiple aliases in one hit. So what I'm going to do is select all the parameters, and then I am going to run the easy alias macro. But before I do that, I'll just quickly show you how to get it and install on your system. So you click on the tools menu, go to the add-on manager, and what this does is allows you to install new workbenches and or macros. So we'll click on the macros tab. We'll go get the list of available macros. And then we simply scroll down until we find the one we want. We click on it. And when it's downloaded all the information, you can click install/update. Now I've already done that, so I don't need to do it again. Now that I've done that, I can run that macro. So go back to the macros menu, go to the list of macros, click on easy alias, and then click execute. And that has set up aliases for all the cells. Now we're just going to add some values. Now I'm going to save this because I'm going to use it as the foundation of all the parts I'm about to design. So we go to File and click Save As. Then we navigate to where we want to save it. And I'm going to call it Specifications. And we'll close the spreadsheet down because we don't need that anymore. I'm also going to save another copy and call it Common Style, because this is the style I'll use for the corner and mitre bridle. I'm going to switch to the part design workbench, and from there I'm going to create a new part and then a body to it, and then I'm going to create a sketch. Sketch will be in the XZ plane. Zoom out a bit. Now the style is a vertical rectangle, so we can create that using the rectangle tool, either by clicking on the icon or pressing the R key. And I'll just press the R key. Now I want it to be symmetric around the origin point, so I'll click the top left corner, bottom right corner, and the origin point, and apply a symmetry constraint by either pressing the S key or using the tool in the toolbar. So I'm going to use the S key. I'm going to set the height of the style using a vertical constraint, which is this icon up the top. Or you can type in Shift and V And because we're going to use this value in the spreadsheet, we'll enter the formula editor by pressing the equal key or clicking on that icon there. And we will set it to be the stile length. And click OK. And we'll do the same sort of thing for the width of the stile by using a horizontal constraint. So we can do that by pressing Shift H or clicking on the tool in the toolbar. I'll use Shift H. And we'll use the formula editor to set the width. So use stile width. Now that it's a fully constrained sketch, we'll close it and we'll use the pad tool to make it into a solid. But before I do that, I'm going to change over to the isometric view, which is how I prefer to look at a lot of these models. And then I'm going to fit the view to the page by pressing the V key followed by the F key. You could also do that by pulling down the view menu and going to standard views and then fit all. Now we're going to create a pad. So we'll click on the pad tool and we're going to use the thickness of the stile from the spreadsheet. So we enter into the formula editor. And we use the stile thickness. And I want the stile to be symmetric to the origin plane so that there's equidistant across either side. So I turn on symmetric to plane and click OK. Now what I'm going to do is create the slot for the tenons in the rail. So to do that, I'm going to create a datum plane, and I'm not going to associate it with any geometry at the moment. I'm just going to leave it associated with the origin. Choose nothing in the parameters and just click OK. And that will put it right on the origin. Now it's just warning me that I haven't done any references, and that's fine. So I'm going to click yes. Then what I'm going to do is I'm going to switch into the model view and click on the datum plane so I can change its parameters. In this case, what I'm going to do is change its position in the Z-axis. So I click on placement, followed by position, and then click on the Z-axis or Z coordinate. And if I make it bigger, you'll see it climb. If I make it smaller, you'll see it go down. Now I'm going to set its position in the Z-axis using the formula, and that formula is half the length of the stile. And when I refresh it, it moves it to the top. Now I'm going to create a sketch that uses that plane. And in this case, I am not going to bring in any external geometry. I am simply going to place a rectangle representing the slot and make it symmetric around the origin point and then set its extents. So I can do that by pressing the R key, which will give me a rectangle. I put it roughly in position. I make it symmetrical by picking the top left, bottom right, and middle point and pressing the S key. I then set its length with a horizontal constraint by pressing Shift H and using the formula editor to set the stile width. And then I set the height of the slot using a vertical constraint by pressing Shift V and use the formula editor to get the slot width. Right, so constrained sketch, so we can close that. And now I'm going to use the pocket tool to make the slot depth the same as the width of the rail. So click on the pocket tool. We're going to use a formula editor to get the rail, the rail width. Click OK. Save that. In fact, we'll turn off the datum plane first by clicking on it and then pressing the spacebar. Save it again. So that's our common style. So we'll close that one down. Now I'm going to create a rail for the corner bridle. So I'll open up the specifications model and then save that as corner mitre rail. I'm already in the part design workbench, so I'm simply going to create a new part, then a body, and then create a sketch. Again, we'll do it in the XZ plane. We'll draw the rail as a horizontal rectangle by pressing the R key and then picking the points. It will be symmetric around this center or origin point, and we'll do this using a symmetric constraint, pressing the S key. We'll set the length of the rail using the horizontal distance constraint by pressing the H key, the Shift H key, and use the formula editor to get the rail length. Zoom out a bit, and we'll set the width of the rail using a vertical constraint by pressing the Shift V keys, and get the rail width from the spreadsheet using the formula editor. Close that. We'll fit to view by pressing V followed by the F key, and then we'll pad it out to be the thickness of the rail. Again, we want it symmetric around the plane, and we want the distance or length of the pad to be the thickness of the rail, which is in the spreadsheet. So we press the equals key to bring up the formula editor and get the rail thickness straight out of the spreadsheet. Now we will create the tenon at the end. So this time we're going to create a datum plane on the top face, and I'll select the face. I'll create the datum plane, and then I'm going to disassociate it from it. I'm doing it this way to try and avoid the topological naming problem. I've linked a video at the top if you'd like to learn more about that. Then going to create a sketch and reference that datum plane. And then I'm just going to place a rectangle. For some reason, the underlying part hasn't shown up, so I just close the sketch so I can see where I've put it, and then I'll reopen the sketch by double clicking on it, and now it's come in. Maybe it's a bug, I'm not sure. So in order to model the tenon, I'm going to model the waist, which will be removed, and leave the tenon there. So to do that, I'm going to use this rectangle, which represents one side of the waist. I'm going to use a vertical distance constraint to set the upper limit of the waist, and the distance is going to be half the thickness of the rail. So we press Shift V and then enter the formula editor by pressing the equals key. Rail thickness divided by 2. We'll set the length of the waist using a horizontal constraint, and that's going to be the length of the width of the stile. And we need to fix the end of the waist to the end of the rail. So we'll do that with a horizontal constraint. We'll use the origin point and the top right corner of the waist. Use a horizontal constraint, pressing Shift H, and this going into the formula editor to set the formula to be half the length of the rail. The only thing remaining is to determine how high the waist is going to be. And to do that, what we're going to do is use another formula. And because the thickness of the rail is less than the thickness of the stile, we're going to determine the amount of waste to remove by a formula which is the width of the rail minus the thickness of the slot in the stile divided by 2. And that's not quite right. What did I do wrong? Oh, I would rail width. It's the thickness of the rail, not the width. That looks better. What that formula will do is if I change the thickness of the rail, it will automatically recalculate the height of the waist and leave the resulting tenon the same width, which is what I want. So now we've got a constrained sketch, so I'll close that and we will use the pocket tool to remove the waist, and then we will mirror that on the other side to reveal the tenon. So we use the pocket tool and we're just going to push the pocket all the way through. Click OK. So now we're going to mirror it. We select the pocket, we click on the mirror tool, and we're going to click on the base XZ plane to remove the second side of the waist and click OK, which leaves us the rail with the tenon. Going to turn off the datum plane because we don't really need that now, and save that. Now we're going to do a quick assembly of this, so we'll create a new drawing. We will save that as corner assembly, and we will switch to the A2 Plus workbench, and we'll import the common style, and we'll import the corner mitre rail, which is badly named because it shouldn't be a mitre. And now we're going to bring the joint together by making the appropriate faces coincident to each other. So I click on a face on the tenon. I click on the corresponding face in the stile, and I use the plane coincident constraint. Click yes, accept. Switch back to isometric view, fit, and you can see that that has aligned it front to back. Now we need to align them vertically. So we click on the bottom face of the rail and the bottom face of the slot, and then use the same constraint, the plane coincident constraint, and click accept. And as you can see, they're now aligned vertically front to back, but not left to right. And the problem with the way it is at the moment, I'm going to find it difficult to get the access to the faces. Going to click on the rail, and I'm going to use the transform tool to pull them apart temporarily, like so. And then I can select this face on the shoulder of the tenon, and then I can select this face on the rail, make them coincident, and everything is where I expect it to be. So now we're going to move on to modeling the rail for the T-bridle joint. So I'll close those. I'll reopen the specifications model, and I will save that. So I'll name this one correctly. It is a T-bridle rail, not a T-mitre rail. We switch back to the part design workbench. We create a part, create a body, and then a new sketch. Again, it will be in the XZ plane. The T-bridle will have the waist cut in the middle. So we will create a new datum plane without any references. It's fine. We will again move its position to be half the width of the rail, or move its position by half the width of the rail. So we get that from the spreadsheet. Refresh the view. Then we will create a sketch and use it. In this case, I'm going to just place two rectangles somewhere near the center. We'll fix that up shortly. Close it and then reopen the sketch to see where they actually went. All right, so we're going to do the same sort of process. The vertical distance from the origin point to the top of the waist is half the thickness of the rail. So we do that using a vertical constraint by pressing Shift V, then go into the formula editor by pressing equals and defining that value, rail thickness on 2. Okay. The waist is also symmetric around the vertical axis. So we select the two endpoints and the vertical axis and place a symmetry constraint by pressing the S key. The height of the waist is the same in both cases, so we make them equal using an equality constraint by pressing E. We make the two waists symmetric around the horizontal axis by clicking on the two endpoints and the horizontal axis and applying a symmetric constraint. We also make the endpoints vertical by clicking on the 2 points and pressing the V key, or using the V constraint, vertical constraint, sorry. The length of the 2 waists are the same, so we set them using an equality constraint. We set the length of the waist to be the width of the rail. So click on the length, press Shift H for a horizontal constraint. Enter the formula editor by pressing the equals key and getting the width of the waist from the stile. The last thing we've got to do is determine how high it is. In this case, we're going to do something different. We're just going to simply set a vertical constraint by pressing Shift V and using the slot thickness defined in the spreadsheet. So that is the stile slot thickness. We now have a fully constrained sketch. We can close that and then just create the pocket. Again, it's just going to be pocketed all the way through. And we're done. We can turn off the datum plane. And we'll do another quick assembly just to show what it will look like. So create a new model, save that as Bridle assembly, switch to the assembly, A2 plus workbench, pull in the parts, and then just start applying coincident constraints. Okay, and as you can see, it is now as intended. And we'll move on to modeling the mitre bridle joint. So we'll close these models down. We'll reopen the specifications. We'll save that as mitre bridle rail. Quickly draw that up. It's much the same as everything else I've done. Now we're going to create a datum plane on this face, model the triangle which represents the waist that we'll cut away, and then we'll go back and create the stile. So select the face, create the datum plane, detach it from the face. Now we'll create a sketch on the datum plane, and we'll draw a rough triangle which we'll fix up shortly. Close that, reopen the sketch so we can put it in context to the rest of the rail. The horizontal distance from the base of the triangle to the origin is half the length of the rail. So we'll put it in a horizontal constraint, pressing Shift H, and enter the formula editor by pressing equals, and get the length of the rail and divide it by 2. The vertical distance between the top of the base and the origin point is half the width of the rail. So we'll set a vertical constraint, pressing Shift V, and use the formula editor to divide the rail width by 2. The length of the base of the triangle is the width of the rail. So we use a vertical constraint and just get the rail width straight out of the spreadsheet using the formula editor. And the length of the triangle is the width of the stile. So we use a horizontal constraint and then use the formula editor to get the stile width out of the spreadsheet. Then we use the pocket tool to remove the waste. And the waste is going to be the thickness of the rail minus the thickness of the slot divided by 2. So we use a formula editor to do that. So it's rail thickness minus spreadsheet.slot thickness divided by 2. Click OK. Turn off the datum plane. And now we're going to use the mirror tool to mirror it onto the other side of the rail. So we click on the pocket, click on mirror, and we'll use the base XZ plane. Click OK and save that. Now we'll move on to designing the stile. And to simplify things, we'll just open up the common stile, make the necessary changes and save that. So we'll open up the common stile and we'll save that as mitre bridle style. Going to create a sketch on this face and remove a triangular portion of waste. So we will create a datum plane and disassociate it from the face. Then we will create a sketch and we will mock in the rough triangle. Close it just to make sure we put it in the right side. And the vertical distance from the top of the triangle to the origin point is half the length of the stile. So we put in a vertical constraint by pressing Shift V. Then use the formula editor to set that value by pressing equals, getting the stile length from the spreadsheet and then dividing it by 2. Oops. The horizontal distance from the side of the triangle to the origin point is half the width of the stile. So we set a horizontal constraint by pressing Shift H and use the formula editor to work that out. Stile width on 2. The width of the top of the triangle is the width of the stile. So we put in a horizontal constraint by pressing Shift H and just simply use the equation editor to get the stile width from the spreadsheet. And the height of the waist is the width of the rail. So we put a vertical constraint and just get the width of the rail from the spreadsheet using the formula editor. Oops. And we've got a constrained sketch, so we can close that. And then we're going to use pocket. And in this case, we're just going to push the pocket through everything. So we change the type to through all. Click OK. And turn off the datum plane. And now we will assemble it. So we create a new model, switch to the A2 Plus workbench, save the model as mitre bridle assembly, import the rail and import the stile. Now, as you can see, they're not going to go together very well like this at the moment. So I will just rotate the rail 180 degrees. So using the transform tool, and then just dragging on the right ball, the red ball, until it comes around 180 degrees. And then it's just a matter of applying the constraints as we normally would. Isometric view and fit it, and you can see it's gone together as expected. This is the first FreeCAD demonstration I've recorded with the camera running, and there's a few wrinkles to iron out, but I hope you found that it was interesting. If you'd like to support me, there's a link in the description below that shows you how to buy a cup of coffee for me. This will just go to providing extra resources for the channel and hopefully improve the quality of the work that I'm doing for you. If you liked the video, please click the like button, and please leave any comments or topic suggestions in the comments below. Please consider subscribing to the channel and clicking the notification bell so you stay up to date with my videos. Thank you for watching. See you next time.